Alrighty, you guys, here's a second video about factoring. The first one was how to factor out a common factor and how to recognize difference of squares. So in the first three examples we're going to do today, we're going to factor trinomials. Trinomials, remember, tri means three have three terms. So 1, 2, and 3 are all examples of trinomials. Number 4 is not a trinomial. Number 4 is called a binomial. It's just kind of an extra that I put on here from yesterday. So first of all, when factoring trinomials, when a is equal to 1, we have like a strategy or a trick. Okay, the trick that I'm going to teach you today does not work if a is not equal to 1. So remember, a is your leading coefficient. So here a is 1, here a is 3, here a is 1. Let's take a look. So on the first one, we have a trinomial, a is equal to 1. So if it's factorable, first of all, we have to look if there's a common factor. In this case, is there anything we can divide these three terms by? Unfortunately, we can't take out any numbers. There's x in 56. We can't take out a variable. So no, there's no common factor. It's not the difference of two squares because there's three terms, not two. So in this case, the last thing to try is to put two sets of parentheses. And you know the only way to get x squared is x times x. And you know that the numbers here, in the second position, have to multiply to 56. So to list out my factor pairs of 56, I have 1 times 56. I have 2 times 28. I have 3. Does 3 divide 56? No. Does 4 divide 56? Yes. 4 times 14. 5 doesn't, 6 doesn't, 7 times 8. So these are my factor pairs of 56. So those are the only possible options. Let me go ahead and zoom in here. But when a is equal to 1, you can use the trick of picking what factor pair adds to 15. In this case, we see that the factor pair that adds to 15 is 7 and 8. 7 times 8 is 56, and 7 plus 8 is 15. So we have, in this case, they're positive. So positive 7 plus positive 8 is positive 15. If we multiply it here, we'd see we'd get 8x plus 7x would give us our 15x. Number 2, common factor. Yes, we can factor out a 3. So when I say factor out, basically you divide. So if I divide this term by 3, I get x squared. Divide this term by 3, I get negative 1x. And if I divide this term by 3, I get negative 30. Now, just because we could factor out a common factor doesn't mean that we're done. So in the next step I want to look at is this is not the difference of squares, but it's a trinomial where a is equal to 1 now. So I'm just going to try to find two numbers that multiply to 30. So factor pairs of 30. 1 and 30, 2 and 15, 3 and 10, 5 and 6. Now in this case, these factor pairs have to add to negative 1. So obviously, now it's not always the middle two, it just happens to be with these last two examples. I know that 5 and 6 have a difference of 1. So I know x times x is x squared, and I know that is plus 5. Now when a is equal to 1, it doesn't matter where you put the 6 and the 5. I could have put plus 5 over here and minus 6 over here. There's no special combination. But I can see here if I were to check my work, I'd have positive 5x minus 6x. Those two terms would combine to negative 1x. And I can't factor that guy further, and I can't factor that guy further. So I know I'm done. Example 3, first step, is there a common factor? No. This is not the difference of two squares, but I see a is equal to 1, so I can try to break it down using my factors of 72. 1 times 72, 2 times 36, 3 times, let's see, 3 times 24 would give me 72. 4 times 18 is 74. And 7, 8 times 9. Wow, I just happen to always pick these middle numbers. So in this case, the two numbers that Again, add to -1 would be -9 and +8. So x minus 9, x plus 8. Factor that further. This is the difference. This is a perfect square, but this is not a perfect square, so I know I'm done. I can't factor any further. Okay. Just a trick to you guys, when I was doing my division here, I knew 2 divided 72 because it was even, and when I was trying to see if 3 divided 72, I saw that 3 divided 36, which was a number I already had written down, so then I knew that 3 had to divide 72. So what I did, if you can follow me, is since I knew that 2 times 36 equaled 72, and I knew that 3 divided 36, what I did is basically broke this down. So I knew that 3 times 12 was 36, so that means that 3 times 12 times this 2 will equal 72. So when I was trying to figure out 3 times what equals 72, I said, oh, that must be that 3 times 24 equals 72. And that's how I got that number there. Likewise here, I said, oh, 4, does it go into 72? Yeah, well, it goes into 24. So since I knew 24 times 3, then I just went ahead and did 6 times 3 to get 18. So if you can follow that, use it, but it's just division without a calculator. Number 4. All right, so this is not a trinomial, but an example that I wanted to do to show you guys. In this case, number 1, no common factor, but I see it's the difference of 2 squares. I know that x to the 4th is x squared times itself, x squared times x squared. I know 16 is a perfect square. It's 4 times 4. So that means this is the difference of 2 squares, which we always have a plus and a minus. So it's always this plus this and this minus this. So x squared plus 4, x squared minus 4. And this is why I did this example, is because now if I look what I have in each set of parentheses, I can't factor x squared plus 4 any further. But if I look here, x squared minus 4, you guys, is difference of squares again. I see that this is x times x gives me x squared. 2 times 2 gives me 4. So it turns out that the original problem was difference of squares, and even one of its factor was difference of squares. So this guy would break down into a smaller set, plus, minus, x plus 2, x minus 2. And I can't factor the sum of squares. There's no such thing. Now if I look, this can't be factored further, this cannot be factored further, so we're done. So sometimes you can do 4 different steps. If this had a common factor from the beginning, we would have had a common factor, a difference of squares, another difference of squares, and finally we're done. So that's what makes factoring challenging, but in the end, look at each set of parentheses and make sure on its own that you can't break it down any further, that there's no common factor and it's not difference of squares. All right, you guys, I will be here hopefully tomorrow by 8 o'clock. If you'd like more help or you'd like to simply come in and check your answers to the quiz review. It will be due at the beginning of the period before the quiz, since it is a review for the quiz. Have a great night.